The bombs that Kim Jong-un would most likely use are dirty bombs. Dirty bomb is now a term for a radiological weapon, a non-nuclear bomb that disperses radioactive material that was packed in within a bomb. When the bomb explodes, the scattering of this radioactive material causes radioactive contamination, a health hazard similar to that of a nuclear fallout. One of the most publicly stated fears of the Western governments since the September 11, 2001 attacks has been the terrorist detonation of a dirty bomb in a populated area. Dirty bombs, similar to other enhanced fallout weapons of more technologically sophisticated design, or aerial denial weapons that could potentially render an area unit for habitation for years or decades after the detonation. In the estimation of most analysis, though, the effect would primarily be psychological and potentially economic if a costly cleanup effort was called for. However, what North Korean dictator Kim Jong-un didn't know about nuclear weapons is that a nuclear weapon is a weapon that derives its energy from the nuclear reactions of fission and/or fusion. Even the smallest nuclear weapons are more powerful than all but the largest of conventional explosives, while the largest can destroy an entire city. Nuclear weapons have been employed only twice in warfare. First, on the morning of August 6, 1945, when the United States dropped a uranium gun-type device entitled Little Boy on the Japanese city of Hiroshima, and 3 days later a plutonium implosion-type device named Fat Man on the city of Nagasaki during World War II. Testing accounts for the rest of more than 2,000 nuclear detonations, chiefly by the following 7 nations: the United States, the Soviet Union, France, United Kingdom, China, India, and Pakistan. Fission product. Fission products are the residues of fission processes. In a nuclear reactor, the buildup of fission products in the fuel eventually leads to loss of efficiency, and in some cases to instability. They contribute most of the short and medium-term radioactivity of high-level nuclear waste produced from the spent reactor fuel. They also appear to some extent in the primary coolant. For fission of uranium-235, the most common fission products inside isotopes are iodine, calcium, strontium, xenon, and barium. Nuclear fusion is a process in which two nuclei join, forming a larger nucleus and releasing energy. Nuclear fusion is the energy source which causes stars to shine and hydrogen bombs to explode. It takes considerable energy to force nuclei to fuse, even those of the least massive element, hydrogen. But the fusion of lighter nuclei, which creates a heavier nucleus and free neutron, will generally release even more energy than it took to force them together, an exothermic process that can produce self-sustaining reactions. The energy released in most nuclear reactions is much larger than that for the chemical reactions, because the binding energy that glues a nucleus together is far greater than that energy that holds electrons to a nucleus. The atomic bomb, also called the A-bomb, is a destructive weapon marked by its great explosive power. It works on the principle of nuclear fission, in which uranium-235 or plutonium-239 is used to undergo fission. When a neutron strikes the nucleus of an atom of uranium-235 or plutonium-239, the nucleus fissions or splits. During such process, a great deal of gamma rays and thermal energy are produced, in addition to 2 or more neutrons that are set out to split the surrounding nuclei, forming what is referred to as a chain reaction. The amount of energy produced during fission is relative to the material involved. It is estimated that 1 kilogram of uranium-235, when completely fissioned, releases amounts of energy that are equivalently produced by 17,000 tons of TNT. The thermal energy released in an A-bomb explosion may reach temperatures of several million degrees, forming a huge fireball great enough to ignite ground fires that can destroy an entire small city.